In this video, I will discuss King's rule of integration. The rule states that integral of the function f of x with respect to x between the limits a and b is same as integral of the function f of a plus b minus x with respect to x between the same limits a and b. We will try to understand this rule. First, some basics. Consider general function f of x. So as x varies from -2, -1, 0, 1, 2, so on like that, you will take values f of -2, f of -1, f of 0, f of 1, f of 2, so on like that. Next, consider function f of x minus a, where a is a positive number. For example, say a equal to 2 in this particular demonstration. So this function f of x minus a will take a value f of 0 when x is 2. When x is 2, 2 minus a, which is 2, it will take a value of f of 0. At x equal to 3, 3 minus 2, it will take value f of 1. X equal to 4, 4 minus 2, in this particular demonstration, a is 2, so it will take a value f of 2. So f of 0 has come here, f of 1 has come here, f of 2 has come here. So this function f of x minus a is f of x shifted towards positive x by an amount 2. So this function is f of x shifted towards right of the x-axis by an amount a. In this case, a is 2. Next, consider this function f of x plus a, where a is a positive number. So we'll take a value f of 0 at x equal to -2, because at x equal to -2 plus 2 is 0. X equal to -1 plus 2 plus 1. So we'll take value f of 1 at -1, x equal to -1. And at x equal to 0, we'll take a value 0 plus 2, f of 2. So compared to this function, f of 0 has moved here, f of 1 here, f of 2 here. So here it is shifted left. So to get this function f of x plus a, take this function f of x, shift left, that is towards the negative x-axis, by an amount a, where a is a positive number. Next, consider this function f of minus x. So this function f of minus x will take a value f of 2 at x equal to -2. F of 1 at x equal to -1, because we put -1 here, it will become +1. It will take a value of f of 0 at x equal to 0. At x equal to 1, we will take a value x equal to 1. The y value will become f of -1. At x equal to 2, it will take a value f of -2. So comparing this with this function f of x, f of 0 is there only, f of 1 has gone here, f of 2 has gone here, f of -1 here, f of -2 here. So this function, if I reflect about this, x equal to 0, that's the y-axis, I'll get this function. So this function is f of x reflected about x equal to 0, which is the y-axis. So to get this function, f of minus x reflect the function f of x about x equal to 0, that is y-axis. Next, consider this function f of a minus x. A is a positive number, 2 here. So we'll take a value of 2 at x equal to 0. At x equal to 1, it will become 2 minus 1, 1, f of 1. At x equal to 2, it will take a value f of 0. At x equal to 3, it will take 2 minus 3 minus 1. And at x equal to 4, it will take a value 2 minus 4, f of minus 2. So comparing these two, f of 2 has come here, f of 1 has come here, f of 0 here, f of minus 1, f of minus 2. So to get this function, first reflect the function to get this one, and then shift right by an amount e. So this function is first reflect the function f of x about x equal to, that is y-axis, then shift right by an amount E. So this result will use further. So to get this function, first you have to reflect and then shift. So to summarize, f of x minus a, take the function f of x and shift right by an amount a, and here a should be positive. And f of x plus a, f of x shifted left by an amount a. And f of minus x we can get from f of x by reflecting this function about the y-axis, which is x equal to 0 line. And f of a minus x, first reflect about the y-axis and then shift right by an amount a. Geometrical interpretation of different integral is, it is area under the curve. Different integral of a function, say f of x dx between the limits a and b, this is equal to area under the curve. This is geometrical interpretation. You have to plot this function f of, let it be here like this. So this value is x equal to a, this value is x equal to b, a and b are positive and b is greater than a. So if it find this area, that is the value of this integral. This is a geometrical interpretation of the different integral. Like geometrical interpretation of derivative is slope of the curve. Similarly, geometrical interpretation of different integral is its area under the curve. So this function f of a plus b minus x, first you have to reflect the function f of x about the y-axis and shift right by an amount a plus b. Both a and b are positive and b is greater than a. So a plus b is positive. So this is the function, just an example function. This is the x-axis, x equal to 0, which is the y-axis. A is here, b is here, a and b are positive and b is greater than a. So let the function look like this. So first reflect the function. So a will go to minus a. So this point will go here and b will go to minus b. It will be farther away. And this point will become this point. So this is f of minus 6, which is a reflection of f of x about the y-axis. Then you have to shift this function towards right by an amount a plus b. So thus minus a will go to minus a plus b, which is b. So this point will go to x equal to b. And this point at minus b will get shifted by a plus b. So if we add a plus b to minus b, it will become a. So this point will go to x equal to e. So this function, first you have to reflect then shift towards right. So this is same as reflecting this function about the middle point, which is a plus b by 2. In between a and b, the midpoint is a plus b by 2. So about this middle point, if I reflect this function f of x, I'll get f of a plus b minus x. So this result also we can use. So obviously the area under this curve f of x between a and b and area under this reflected curve, which is reflected about a plus b by 2, are same because the same curve. So the area will be same because just the reflection of this curve or flipping of this curve about the middle point. And these two areas are equal, that is nothing but the King's rule. Area under f of x, this area, so this area f of x, area under the curve f of x, and this curve f of a plus b minus x is nothing but reflecting this curve about the middle point a plus b by 2. So obviously that area will also be same. So this area because it is the same curve reflected above this middle point. So both these areas are same, which is the King's rule. So this is in some sense deriving or understanding the King's rule based on the interpretation, geometric interpretation of integration, which is area under the curve, and also you should have an understanding how the function f of a plus b minus x is related to f of x. So this King's rule can also be proved algebraically, which you can find in all the books. So this variable a plus b minus x, I can call this a new variable x1. So from this, the right hand side will become integral. This limit is from x equal to a to x equal to b. So x equal to a to x equal to b of the function f of new variable x1, and dx and dx1 are related. Differentiate both the sides, I'll get minus dx equal to dx1. Differentiate both the sides, a and b are constant, become 0. Minus dx differential is dx, dx1 differential is dx1. So dx is nothing but minus dx1. So when x equal to a, x1 will become b. So the limit in terms of x1 will be b. When x equal to a, you put this thing here, x1 will become b. When x equal to b, x1 will become a. So the limit in terms of x1 is from b to a. Now, observe this negative sign for interchanging these limits. So the limits I'll interchange to a to b, x1 equal to a to b of f of x1 dx1. Now I can change the variables from x1 to x. So integral f of x is just change of variables. So x1 will become x, a to b, which is the left hand side. So this is proof of King's rule using proved algebraically.